And we have our first theorem here. A straight line drawn from the center of a circle to bisect a chord which is not a diameter is at right angle to the chord. So if we have a circle there, and that's the center, and we have a chord, okay, AB is a chord, and we draw a line from the center to bisect that chord at M. Now we can join that way. Now the line is going to bisect the chord into two equal halves. Can you see that there? So AM, the length from A to M, is same as the length from M to B. Remember that the length OA and OB, they are radii and they are equal in length. Remember, the radius of a circle is always of the same length. So that angle AMO, is equal to angle MOB, and it's 90. That's what is shown there. Now note that line OM is a line of symmetry, because it's only a line of symmetry that can divide a triangle. For instance, triangle AOM is being divided into two equal triangles there in terms of area, and there's only a line of symmetry that can do that. So line OM is a line of symmetry, okay? So now, is OM a radius to the circle? The answer is no, okay? But most students, they used to assume this, and that shouldn't be, because OM is not touching the circumference of the circle, okay? Now we have an example. Find the distance, okay, of a chord. That chord is 8 centimeters long from the center of a circle, and the radius is given as 5 centimeters. So we can complete the diagram that way. Now we know that the distance from A to M is equal to distance from M to B, okay? And so we can divide the length of the chord by 2. That will give us 4. Now we can separate this diagram, okay? So that's 4. Now we can use Pythagoras theorem to find the distance from O to M. So the square of the hypotenuse equals the square of the other two sides. So by the time we simplify, we get OM as 3 centimeters. So that's the height, the distance rather, from the center to the chord, okay? So now we have another example. Find the length of a chord which is 5 centimeters from the center of a circle. Now this time the radius is given. Okay, so they are giving us the radius of the circle and the distance from the center. Okay, so that's how the diagram will look like. Now we can separate those two and use Pythagoras theorem to find the distance from M to B. Now we're going to get MB as 12 centimeters. So if MB is 12 centimeters, AM will also be 12 centimeters. Therefore, the length of the chord, which is AM plus MB, will be 12 plus 12, which is 24 centimeters. Okay. We have an example here. If two parallel chords AB and CD are on opposite sides of a circle of radius 8 centimeters, and if AB is 12 centimeters and CD is 10 centimeters, find the distance between the two chords. So we have a circle with center O. We have one chord which is 10 centimeters long. Okay, that's CD. We should join the center to the chord and to bisect it at N. Okay. We join the radius, which is 8 centimeters. Now the second chord is 12 centimeters. Now we should also join the center to the second chord, which bisect at M, and that's 90, and that angle is, that distance is 8 centimeters. Now that line bisects that chord in 6 centimeters by 6 centimeters. Okay. And at the other side, it's also going to bisect chord CD in 5 centimeters by 5 centimeters. Now the distance between the two chords is the distance from M to N. Okay, and the distance from M to N is equal to the distance from O to M plus O to N. So we need to find those distances. Now in triangle AMO, we use Pythagoras theorem to get the distance OM. So OM will give us 5.29 centimeters. So we use triangle CNO to find the distance ON. Again, we use Pythagoras theorem. Square of the hypotenuse, which is 8, equals sum of square of the other two sides. That will give us ON as 6.25 centimeters. Therefore, the distance between the two chords is now 5.29 plus 6.25, which is 11.24 centimeters. Now we have another example. An isosceles triangle PQR is inscribed in a circle. Okay, let's just start somewhere there. Isosceles triangle inside a circle, that's what we have there. PQR. Now in an isosceles triangle, two sides are equal, and the two equal sides here are PQ and QR. So PQ is 17, QR is 17, the other side 16. Now we have to calculate the distance of the midpoint, okay, B of PR from Q. Now what we are saying is that distance, we have to find that distance. Now note that that line is a line of symmetry, because an isosceles triangle has one line of symmetry that runs through that way, and it's going to make the angle 90, and it's going to bisect also. Okay, now B is the midpoint of PR, so that's it. So it bisects PR in two equal halves. Okay, and those halves are 8, 8. So dividing 16 in 2, that's 8 centimeters. Okay, good. So I guess we have our diagram already. Now in triangle BRQ, that's triangle BRQ. Okay, we are going to use Pythagoras theorem to solve to get BQ, which is the distance of the midpoint B from RP. So the square of the hypotenuse is the square of the other two sides, equal to the sum of the square of the other two sides. So by the time we solve that, we are going to get QB as 15 centimeters. So we've answered the first question. Now to find the radius of the circle, I'm going to use the remaining half of the triangle that is inside the circle there. Now I need to make a construction. I must join O to P. See that? Now the distance O to P is a radius. Okay? So is the distance O to Q. Now what I do is that I know that QB, I need to find an expression for the length BO. Okay? Now QB is equal to QO minus BO or OB. So OB is actually QB minus QO. Now that's it. So that is a radius QOQ. Okay? That is also a radius. Alright? Now remember that the distance from Q to B is 15. Okay? So if that's 15, then distance from O to B will be 15 minus R. Can you see that? So that place will be 15 minus R, because the distance from Q to B is 15. The R is the R OQ, the R for OQ or QO. So I'm going to use Pythagoras theorem in triangle. I either use triangle POB or I use triangle PQB. Can I really use triangle PQB? I don't think so. If I use triangle PQB, my R will cancel out, so there will be no R to find. So that's why we have to use triangle POB. Okay, so you can see triangle POB, that's it. Okay, if I bring it out there, that triangle is what I will use. So in triangle POB or BOP, the square of the hypotenuse, which is PO, equal to the sum of the square of the other two sides. I will expand that side, and when I expand, I get 225 minus 15R minus 15R plus R square. 15R plus, okay, I carry R squared the other way. That's what I'm doing first. It becomes negative. R squared minus R squared is 0. Minus 15R minus 15R minus 30R. Divide both sides by 30. So the radius is 19 over 30 centimeters. That's the radius of the circle. Okay? Now do this yourself. A chord is 12 centimeters long and 4 centimeters from the center of the circle. Find the radius of the circle. That should be that's your answer there. The second question, an equilateral triangle this time is inscribed in a circle. Calculate the height of the triangle, then the radius of the circle. That should be your answer. So make sure you do these exercises yourself, okay? So that's a hint for that particular question.